Okay, so what is up, guys, and welcome back. Today we're going to be starting from the fundamentals of parabolas. Fundamentals of parabolas. So let's get into the video. So what is a parabola? A parabola is a graph of a quadratic relationship where x to the power 2 is the highest power of x. So it's a quadratic relationship where x squared is the highest power of x. So all quadratics will have an x to the power of 2, and all quadratics will be a curve when they're graphed. That's just a property of all quadratics because they're all symmetric. Symmetric about the y-axis. Now let's actually get into the theory. So before we get into anything, let's just look at the forms how you can express a parabola. There is one, yes, the general form. What is the general form? That's the most commonly used form, which is the ax squared plus bx plus c is plus c. That's why. Then there is the vertex form. This form is very useful when, we're either given the vertex or we're asked to identify the vertex. So it's very useful when we're given the vertex mainly. So this form goes like y is equal to a x minus h all squared plus k. Okay, right. And we have the intercept form. This is very useful for, finding the x-intercepts and therefore the y-axis of symmetry and correlatingly the vertex. And this form goes like a x minus b x minus g. And we also have the basic form, which is y is equal to x squared. All of these are y. So all of these are y is equal to. What happened there? Okay. Now, what you can see is that some of the letters are the same, such as this a bit. What is this a? This a states how skinny. This a states how skinny or fat the parabola is. How skinny or fat the parabola is. Okay? So let's actually get into the videos. Now, what does y equals x squared look like? This is the very fundamental form of a parabola. So how does this look like and why does this matter? Well, to better understand how this looks like, let's first go on and draw a table of values. So consisting of an x and y. Okay, so let's put -2, -1, 0, 1, 2. You always want to be going in this kind of reverse order. So 0, 1, -1, 2, -2. So that you get both sides of a parabola. Because remember, parabolas are always a curve. So they're always almost symmetric. All right, so let's fill in these values. So in the function y is equal to x squared, when you sub in x is equal to -2, well, -2 whole squared is equal to 4. 1 whole squared is equal to 1. 0, 1, 4. See how it's symmetric? It's 0, but then the same things repeat afterwards. That is what we mean by symmetric about the y axis. Now, oops, I dropped my pen, but nevertheless, this will result in a symmetric shape. And when we actually take the effort to sketch this, right? Let's say that point is 0, 0. Then we got, let's say that's 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. Let's say that's 1, 1. That's 1 comma 1, and then that's minus 2 comma 4, and that's minus 2 comma 4. Now when we actually go on and sketch this, it's going to look like this. Okay, that's an alright shape. And let's label this y is equal to x squared. See how it reflects all the values on this side, right? They're the same as the values on this side. Why? Because the parabola, it does the values here, and then it reflects above the y-axis. This is the y-axis. It reflects above the y-axis. All right, gotcha. Now, let's move on. So special features of this basic parabola include the fact that its vertex, or this bottom point, or let's say if the parabola is concave down, this top point, the vertex lies at 0, 0. Okay, right. The axis of symmetry, AOX, lies at 0, and this system, this function has both an x and y intercept. Right, gotcha. Right, so let's move on. Now this is term called concavity. Concavity refers to whether it refers to the reflection or where the parabola is. So let's say the a term, right? You know how there's this ax squared plus bx plus c. You know how this ax, if this a is positive, then the parabola is facing upwards. We say that this parabola is concave up. But suppose this a, there's a negative in front of the a. Suppose this a is negative, then the parabola is concave down. So it's facing down, so it's concave down. A good way that many teachers teach us to remember this, come on, is using the fact that, if it's positive, it's going to be smiling. That is the wrong color to have used there. But if it's negative, it's going to be sad. Okay? That's what we can use. Positive upwards, negative downwards. Okay? Right. So, when graphed, all quadratic functions are parabolic. I'm repeating this once again because of its genuine importance. But when graphed, everything is like that. Right. Now, we move on to these terms named as transformation. Let's go. Transformation. Transformation. Now, what is transformation? So, transformation refers to, how much it shifts. Now, let me check my book one more time just to clearly tell you what transformation means. So, transformation occurs when a graph is changed in appearance. So, that's a horrible definition, but let's just go on with it. So, transformations are of three types. One is the fact that the vertical, horizontal shifting of the parabola. So one's translation. Two is reflection. And three is dilation. Right. So we got these 3 points. These three are our main points. Translation, reflection, and dilation. What is translation? Translation is the vertical or the horizontal shifting of the parabola. Reflection is when the parabola is mirrored about an axis. Right? These are all reflection. Gotcha? Now, dilation is the stretch of the parabola. So, that's stretched more, this is fatter, all that. So now let's go into each of these. Dilation. Dilation is probably the easiest. It's referred to as the stretch. So even for dilation, all you need to look at is the a term in what? Ax squared plus bx plus c. Just look at the a term. Now, if the a term is, let's say, smaller than 0, then what do you think has happened? And what do you think if the a term is smaller than 0? If the a term is bigger than 0, then, wait, this is a horrible way to go about it. Let's say if the larger the a term, the narrower the graph, and smaller the a term, well, smaller the a term, wider / fatter the graph. Simple? Got it. So large a term means narrow. So let's look at this. If the a term is large, the graph is going to be getting smaller and smaller, right? And if the a term is big, it's going to be getting fatter and fatter. Okay, that's a simple way to go about it. Now, what is reflection? So reflection refers to the sign of A. As I've already said, if A is more than 0, then it's concave up. And if A is less than 0, then it's concave down. I've already mentioned this using a perfect example of that smiley face and sad face. So now let's look at the horizontal and vertical translations. So yes, we're getting finally to the translation part. Now, translation, as mentioned before, is the vertical and horizontal shifting of the parabola. So the vertical translation is determined by the constant y, k, right? You know how this above form here, we had this k determines the translation. So suppose that the k is greater than 0. Then it translates the graph upwards. And if the k is smaller than 0, then it translates the graph downwards. Let me explain what I mean. So take an example such that y is equal to x squared plus 2. In this example, we know that the function y is equal to x squared. Let's plot it. We know it's the basic form, so it's easy to plot. So y is equal to x squared is just this parabola. Y is equal to x squared is just this parabola. Y is equal to x squared. Now, what does this plus do to it? We realize we have this plus 2, but what really can it do? Well, all this plus 2 is doing is shifting the graph upwards by 2 units, right? So see how the origin of this graph, or like the vertex, it lies at 0, 0. It's pushing it 2 units, 1, 2. So now this plus 2 is basically pushing the graph, everything, by 2 units. So the new graph will look something like this. Right? It follows the same characteristics and all, but everything is just pushed up. Every point is pushed up 2 units. If you push up 2 units, every point will come up. So every point is pushed up 2 units. So what if, let's say, it was y is equal to x squared minus 3? What happens? So we would draw our normal, what do you call this one again? Y is equal to x squared. But then we would just shift it down 3 units. We would go down the graph 3 by 3 units, the entire thing. So our vertex, it would be at 1, 1, 2, 3. It would be there, and we would start the graph there. So the graph would look like this. It's not like it's far, but it's just going to start this way. Right? The graph will just start lower. It's the same graph and all, but it's just going to start there. Okay? Now, sure, for vertical translation, yeah, we could just, make 3x squared minus 3, and we could say that this 3 refers to the graph getting narrower, and this minus 3 refers to the graph getting, going down 3 units. But then how do we change the horizontal translation? We've seen that we can change the vertical shifting of the graph. How do we change the horizontal shifting of the graph? How do we change this? Well, this is where our intuition comes in. Let's think. When you take a look at, y is equal to x squared minus 3, where the graph goes down 3 units. Let's rearrange it, right? X squared is equal to y minus 3. X is equal to root y minus 3. Did this help you at all? No, in no form, because I was stupid. So let's get it back into the video. Horizontal translations, well, that is expressed in the form x minus h whole squared. Here, you are directly changing h. H is the value. H is the value changing the x value. See how it's all whole squared under the x bracket? That's how you know that you're actually changing the horizontal direction. So when you see that y is equal to x minus h whole squared, that is a shift in the horizontal and vertical direction. Okay, so we would draw our normal graph, y is equal to x squared. But then when you see that y is equal to x minus 3 whole squared, many of us will be tempted to believe that because, okay, yeah, sure, it's a minus 3, so let's go from here, left 3 units, 1, 2, 3, and draw the graph like that. I mean, I made the same mistake, so don't be worrying. But no, that's not what you do. You see how it's inside the bracket, that x minus 3? Well, if we let y equals 0 to find x, that x minus 3 is equal to 0, so x is actually equal to 3, not minus 3. So it's actually in the positive direction. So it's 1, 2, 3, and the graph is supposed to be here. So that's everything. So the easy trick would be to just opposite it instantly. So y is equal to x minus 6 whole squared. You're seeing this, yeah, sure. Now, you see the minus 6, right? You're not going left anymore, you're going right because there's a minus, okay, opposite, plus, right? So we're going to the right now. That's what you always should be doing. The minute you see the question, you should be like, okay, right, opposite, next. Okay, right, opposite, next, right? Gotcha. Now that was the horizontal translation concept covered. Now, let's look into the axis of symmetry. Axis of SYMMETRY. For the rest of the video, I'll be just referring to the axis of symmetry as the AOS. I'll be referring to axis of symmetry as AOX. I'm not sure why I'm doing this, but that is just what we'll be referring it to. Right. So axis of symmetry can be given by the rule minus b over 2a. What is the axis of symmetry? Well, this axis of symmetry is the so-called imaginary line where the parabola shifts. So for the common basic form, y is equal to x squared, suppose this is touching the bottom, the middle, or where the parabola touches the vertex and starts going the other way, starts turning the turning point that way, that is at 0. X is equal to 0, because that's a basic form parabola. But for most parabolas you'll encounter, it's possibly not going to be at the center. So you want to be able to find where the turning point is, the vertex, and where it starts unfolding. That's why the axis of symmetry is very useful, right? So let's take a simple example to figure this out. Take, for example, this problem. Y is equal to x squared plus 6x plus 5. Okay? So in this problem, we want to be sketching, we want to be doing everything. So I'll explain you step by step. What you want to first do is this simple rule that I've created for myself, which is the yx aox v with the underline on aox. So first find the y-intercept, the x-intercept, the axis of symmetry, and the vertex. Right? We'll highlight them as we go. First, to find the y-intercept. We know, because this is in the general form of the parabola, this c, ax squared plus bx plus c, this c is equal to phi. C is equal to phi is equal to y-int. If you didn't know that already, c is equal to y-intercept, because when you let y equals 0 to find x, y will come up to be 0, right? So let x equal 0 and you'll get y is equal to phi. Or, easy way, you see c, instantly, yeah, boom, y-intercept is phi. Now what is x-intercept then? X-intercepts are more tricky, so this is where you let y equal 0. So let y equal 0. So 0 is equal to x squared plus 6x plus 5. Right. So what you need to now think is, what are two numbers that multiply to phi and add to 6? Think. Two numbers that multiply to phi, add to 6. All I can think of is phi into 1. Phi times 1 is phi, and they add up to 6. So x plus phi, x plus 1 is equal to 0. So either x is equal to negative phi or x is equal to negative 1. So the two axes of symmetry points, or like the two x-intercepts, are minus phi and minus 1. So this graph has two x-intercepts. That's nice to know. Now we figured out the y, we figured out the x. Now what is the axis of symmetry? You know how I earlier said that the axis of symmetry can be found using the formula minus b over 2a? Let's use that. What's b here? We know that b is equal to 6. So minus 6 over 2 a. Well, a is just 1 because we have nothing here. And that will give us y-intercept is equal to minus 3. TK? Simple. Now, vertex. How do we find the vertex? I don't think I've talked about finding the vertex until now in the video. So let's get into it. So the vertex is basically the point where the parabola turns. So it goes down this way, and then at the vertex the parabola starts going the other way. So it's going down, it can just be going down, but it starts facing the other way at this turning point. That's what we want to find, because that will help us immensely. So we find the axis of symmetry is 3, right? The axis of symmetry always goes through the vertex. So the axis of symmetry is the x coordinate. So when you find the axis of symmetry, you're basically finding the x coordinate for the vertex of the parabola. For the vertex of the parabola. But guys, do you want to actually just use this? Do you guys actually want to use this? Let's try using their flat form now. I don't know why I switched all of a sudden, but let's try using theirs. Okay, so x coordinate, that's where we're stuck. Minus 3. So x squared plus 6x plus 5. x squared plus 6x plus 5. That's our thing. And we know that the y coordinate, the x coordinate is equal to minus 3 for the axis of symmetry. Oh, this is a much better writing experience. Let's actually go. W Samsung. Okay. So, x squared plus 6x plus 5. Now, how do we actually do this? Well, you know how we know that x is equal to minus 3? Well, let's take this minus 3 and let's input it into the equation. So minus 3 whole squared plus 6 minus 3 plus 5. When you do this, what comes outside on the other end is equal to minus 4. This way, effectively, we understand that the vertex lies at minus 3 minus 4. So when we're asked to graph the parabola, we know all our information. We know the vertex lies there. We know that the y-intercept is equal to 5. We know that our x-intercepts are equal to minus 5 comma minus 1. And we know our axis of symmetry is equal to minus 3. This is all important information needed for us to start sketching a parabola. So let's actually go. So that's a good graph. And now let's sketch. We know our vertex is at minus 3, 4. So it's 1, 2, 3, 4. So minus 3. 1, 2, 3, 4, 5. Right. 1, 2, 3, minus 3, and then at 4. Our vertex is at minus 3, comma 4. Then we got our axis of symmetry running through this line. Nice. So let's label that x is equal to minus 3. Then we also got our two x-intercepts, which is minus 5 and minus 1. And all we are left to do is actually just to join these lines. So, oops, my bad. All we're left to do, wait, that's actually a horrible diagram. Guys, trust me, I'm having difficulty only because it's the software, but okay. That is a parabola, and if you label the parabola, well, we can label this the original one, which is y is equal to x squared plus 6x plus 5. Right, gotcha. So I have more practice problems. Well, let's get on to the theory first. Now let's look at the forms of parabolas and how we graph the parabolas. So as I said before, that the basic form is y is equal to x squared. So for y is equal to x squared, let's take down the x and the y values. When you take down the x and the y values, when the x is minus 3, we get 9. Minus 2, we get 4. Minus 1, we get 1. 0, we get 0. 1, we get 1. 2, we get 4. And of course, you guessed it, 3, we get 9. It is symmetrical. Of course, that's not the point that we're trying to prove. What we're trying to prove is that when you graph this, you'll be getting 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Hopefully that's accurate. I really can't tell. But let's just go plot these names. So it's minus 3, 1, 2, 3, and then at 9. Minus 3, it's at 9. This is at 3, and then let's say that's at 9. Then minus 2 at 4. 1, 2, 3, 4. These are all symmetric, so gotcha. Let's just draw this parabola. Right? Then let's take a look at the parabola, that is y is equal to 2x squared. When you actually draw a table of values for this one, you can easily identify that when x is equal to, let's say, -2, y, -1, 0, 1, and 2, well, the corresponding values are equal to 8, 2, 0, 2, 8. Let's catch that. When x is -2, the corresponding value is equal to -8 up here. And this is only a 2. When x is -1, it's a 2, and that's 0. So what we can see is that from the second line, I know this drawing is horrible, but just manage, that when you add this a in front of it, this is in the ax squared form. When this a is bigger, the graph gets narrower or smaller. Okay, right. So let's try one more example for the sake of things. X, y, let's try this, and let's go, I don't know, 1/3. Y is equal to 1/3 x squared. So going through the same way, -1, 0, 1, 2, we get 4/3, 1/3, 0, 1/3, 4/3. So let's actually go and sketch these points. So 4/3 is somewhere, it's about 1. So when -2, it's 4/3, so it's above 1. And then at other times it's like there, and then it's there. So that's the graph of this y is equal to 1/3 x squared. We see that it's much fatter. It's much fatter, right? That's very visible. Now let's take a look at one last example around this problem. How about when y is equal to -x squared? So it's the same problem but with just y minus. So it's supposed to look like this, but what will it look like? So when you actually do the table of values, this is a very fun method to do because you get all the points and you're just plotting them. So table of values, well, this time let's use, I don't know, green as a color. You get -4, -1, 0, -1, 4. And when you actually go graph that, -2 and then 1, 2, 3, 4. And then that -1 and 1 and 0. We get the exact same graph. We get the exact same graph as this green one, as this red one, which is the y is equal to x squared, except it's facing down. Why? Because it's concave down. So what has happened to this graph to this graph? Well, that exactly is what we called reflection. What kind of reflection is this? Well, this is reflection about the, what axis is this? X-axis, correct. About the x-axis. Simple? TK, guys. That is how simple this is. Now, let's move on. Let's look at vertical translations. I'm actually not bothered to show you guys vertical translations now. So, let's move on to the that y is equal to ax squared plus bx plus c. This form, the one that everyone loves. So, what happens here? Well, Let's just attack all these questions by problems, okay? We've gone through the theory already. Let's go through some problems. Let's say that y is equal to x squared plus 2x plus 3, right? So in this one, we understand that y is equal to 2x plus 3. So we know immediately, bang in our head, that let's write down all the properties that we know. Let's go even thinner. We know that the y int is equal to 3. What else do we know? The fact that it's concave up. We know this is concave up. What else do we know? I don't know. Let's try to find the axis of symmetry. So the axis of symmetry can be given by, minus b over 2a. So what is this minus b over 2a? Well, that's minus 2 over 2, and then a is just 1 in this case. So minus 2 over 2 is just minus 1. So the axis of symmetry is x equals minus 1. So what is the y value? Y value, yeah, we know. So what's the vertex then? So the vertex lies in minus 1 comma something else. What is that something else? So let's put minus 1 back into this equation. Well, doing that will give us minus 1 whole squared plus 2 minus 1 plus 3. That is equal to 2. So that missing number is 2. So right now we have all essential points for us to graph this parabola sufficiently. So let's go on. Let's make our table and let's just get graphing. We know the axis of symmetry is at minus 1. Suppose that's minus 1. Then it's at minus 1 and then 2. It's somewhere there. And then we know the fact that, the y-intercept is equal to 3. It has no x-intercept. Y-intercept's 3. No x-intercept. So with all that given, let's just graph. X is equal to minus 1. Label all these points as always. Concave up. Yeah, good. You can go on and additionally do a table of values to find additional points. And then, label this as maybe 0, 3. Maybe this as minus 2, 3. Who knows? You can do a table of values, but that's up to you. Right. I wanted to do 2 problems from each step, but I think that will be a bit too tiring on my end. So let's just keep going. Now let's look at the vertex form. The vertex form. Golden. So what is this vertex form? This vertex form is when the form gives you the vertex. This form right here is basically handing over. It's handing over the vertex. It's handing over the vertex to you, right? So let's go on about how do we solve. I don't know, guys, I'm just having too fun with these marker points that we have. Right, so let's take an example that y is equal to 1 over 2 x minus 1 whole squared minus 2. That's a pretty bold example. So let's explain what each of these mean. So the vertex, right? Where is the vertex? This is called the vertex form. So what is so special? Well, this point and this point together give you the vertex. You know how this x is inside the brackets? So if we let all the x equal to 0, the y-intercept you'll get. So if you let y equals 0, we'll get the x-intercept such that x minus 1 is under the bracket. So to get it out of the bracket, x minus 1 is equal to 0, x is equal to 1. Simple. TK. So one thing I've previously mentioned in the video too, once it's in the vertex form like that, just opposite it and take it out. So the vertex, if you opposite this one, will be 1, and then this one is the y value. What's that? Minus 2. Yeah, I know that's confusing. So Cash, why did he not opposite this one? Well, take of it as the first one always lies, the second one always tells you the truth. First one always lies, the second one always tells you the truth. Okay, so minus 1, bam, opposite, and minus 2, you keep it as it is. So the vertex is at 1 comma minus 2. Simple. TK. Now where is the axis of symmetry? Well, the axis of symmetry for this graph is at 1. How do we know that? Well, you know how we have this x value to equal to 1 comma x value equal to 1 in this vertex? You know how the vertex is always right in the middle? So the axis of symmetry goes through the x value. So the x value of the vertex is always the axis of symmetry. So if you know the axis of symmetry, you know the x value of the vertex. Therefore, you can substitute it into the equation and find the y value, right? Hope this is all starting to make much more sense now that we're going through more and more questions, right? Now, we forgot to graph that. Let's graph that equation. So we know that the axis of symmetry is at 1. So 1, 2, 3, 4, 1. We know the vertex is at 1 comma minus 2. And, we know both the intercept forms. We know both intercept forms, which is one of the intercept is, oh no, we don't. This is the vertex form. My bad. We can just graph it there. You can go on and do an additional table of values and, get that x, y, get that x is equal to minus 1, 0, 1, 2, 3, 0, minus 1, 1 over 2, minus 2, minus 1 over 2, 0. You can do all that, but I'm just not interested right now. Okay. Right. I'm really getting bored now. But you know what? We've got to keep going. So we covered the vertex form, we covered the general form, we covered the basic form. All that's left for us to cover now is of course, I don't want to write with this pen. Let's write with the cursive metallic pen. Okay. All that's left for us now is it's the intercept all that's left for us is now the intercept form. So what is this intercept form? This intercept form is x minus b, x minus q, ax minus p, x minus q, because p, q are usually integers, but anyways, doesn't matter. So it's the same thing. A value, determines the steepness of all that and everything. And this x value, right? This and that, well, they're basically the x-intercepts. Hence why this is called the intercept form. Now, you might be wondering, how is this intercept form any useful? Well, this intercept form is useful when, because now you have the x-intercepts. Now, what else do you need to know? When you have the x-intercepts, let's say it's minus 1 and 2, you can find the axis of symmetry by doing the midpoint formula, axis of symmetry by finding the median, like by mean, by adding, x plus y over 2. Then, if you know the axis of symmetry, you can find the vertex, and you can use, table of values from there. And then you can just sketch. You can just sketch the parabola, right? Simple. So let's continue on the video. If they're asking us here, let's suppose 2 x minus 1 x minus 3, well, we know that this is going to lie somewhere. Let's firstly let y equals 0. When you let y equals 0, you can say that 2 x minus 1 x minus 3 equals 0. So either x minus 1 is equal to 0 or x minus 3 is equal to 0. So x is equal to 1 or x is equal to 3. So that is our x-intercept. So let's label that 1 and then 3. 1, 3. Then we know that's 1, we know that's 3. We know the midpoint is 3 plus 1 over 2. 3 plus 1 over 2, which is just 2, because 4 divided by 2 is just 2. So that's just 2. And we know the axis of symmetry is also going to lie there. It's 2. So x is equal to 2. So if we know the axis of symmetry is 2, let's find the vertex. The vertex. So the vertex is equal to 2 comma something. Let's sub back 2 into this wonderful equation, which is 2, 2 minus 1, 2 minus 3. That's y. And so y is therefore equal to minus 2. So it's 2 comma minus 2. So 2 comma minus 2, it's somewhere there. It's opening up parabola. So, you know, we have everything we said. We could do table of values now. Just because I told you guys we can do table of values, let's go ahead and do it. X, y. I usually wouldn't do it. I usually would just graph because that's enough information. But let's do the table of values. So we're given the vertex 2 minus 2. So let's put that dead center 2 minus 2. And let's get ones on either sides. Okay. So let's go 1, 0, 3, 4. These are out to be symmetric. So let me have my calculator here. Okay. So when you put in 1 into this equation, what do we get? So 2, 1, minus 1, and then 1 minus 3. Well, we get 0 here, 0 there. And if you put 0 down for both of them, we have to get 6 and 6. Okay. So 0, when it's 0, it's going to be 6. When it's 4, it's going to be 6. When it's 1, it's going to be 0. When it's 3, it's going to be 0. See, we got the x-intercept right, and that way. So now we can just sketch this perfectly. I mean, you know how to sketch it on there, don't you? It's hard to get a perfect sketch on this tab going through all the points. But see, that's about it, roughly good enough. Y is equal to 2, x minus 1, x minus 3. Right? Gotcha. So that is the form, and that is all it labeled. You might just want to label it just so you're safe. But that is actually done. Now, there are some practice problems for you to solve. I'm not going to go through those practice problems with you. But before we finish the video, I do want to go through this with you guys. How to find equation of a quadratic from the graph. I do want to go with this with you. So let's do that. So we want to be finding, quadratic equations, the equation of the graph from, possibly just looking, or like from the points that they give us. So suppose they give us 2 points. The fact that the vertex, okay, let's suppose they give you a diagram, and that diagram's like this: 3 comma minus 4 and another point 4 comma minus 2. Now they want you to find parabola line. They want you to find the equation. Okay, equation toy. Sorry, I tried to speak Hindi there and look cool, but it doesn't matter. Hindi is not cool anyway. Okay, got it. So we're in this form. So because we see the vertex here, our brain should be like, oh, right, it's the vertex form. We have the vertex, so the simplest form is the vertex form. So let me recall, what is the vertex form again? The vertex form is just y is equal to a, even I got it wrong, so it's alright, a x minus h all squared plus k, right? Bam, that's the vertex form. Now, we have the vertex, we have 3. Okay, what's opposite of 3? Bam, minus 3. So it's a x minus 3 whole squared, and then plus, well, that's minus 4, so there's no use to plus, so it's just minus 4. So we know that right now that y is equal to a x minus 3 whole squared minus 4. We want to find y for the equation to be complete. So what can we do now? Well, if you observe the graph close enough, you can find that we have one other set of points given, 4 and minus 2. How can we use this? If you're thinking how I'm thinking, or if you're thinking how I'm thinking at least now, because until me watching and learning, I couldn't think normally. So if you're thinking what I'm thinking, you got to substitute this in. Substitute it in. So let's say minus 2 is equal to a, what is 4? 4 minus 3 whole squared minus 4. So a is subsequently finally equal to 2. Try doing the simplification yourself. So minus 2 is equal to a minus 4, and then minus a is equal to minus 2. So a is equal to 2. Simple. Gotcha. A is equal to 2. So now that we know what a is equal to, what the x-intercepts are, y, like the vertex is equal to, we can come to a conclusion that y is equal to 2 x minus 3 whole squared minus 4. So that is the equation of the line. Equation of the line in vertex form. Now, the interesting fact about this vertex form is the fact that you can come up to the equation of the line with only 2 points. Now, in the test, if they want to make it harder, they can, make you use system of equations, so that you need at least 3 points, and you need to use the standard form of the parabola. Not hard, but this is way easier. So you thought I was going to quit, didn't you? No, I'm going over the last one. So let's go to the lucky last question, right? Okay, so a parabola passes through the points 1 comma 3, 4 comma 9 and 2 comma 1, right? Find the axis of symmetry. Right, okay, simple. So all we're going to do now is first sub in the points. So sub in these points, so that the fact that 3 is equal to a 1 squared plus b 1 plus c. Then the fact this one, let's sub this in, 9 is equal to a 4 squared plus b 4 plus c, and this one, 1 is equal to a 2 squared plus b 2 plus c. Okay, now that we have everything in this format, let's rearrange everything, or let's simplify everything. Simplifying everything, we get that a plus b plus c is equal to 3 for the first one. For the second one, we get that 16a plus 4b plus c is equal to 9. And for the third one, we get that 4a plus 2b plus c is equal to 1. Just, add it all up. This is a, so a 4 squared is 16a plus 4b plus c. That's exactly what we wrote down here. We're just opening up the brackets. Simple, right? Simple. So, right, we have this. Now what we need to do is solve these systematically. So, me telling you to solve them systematically sounds way too cool, sounds way too fancy, sounds way too hard. So, let me break it down. It's very, very simple. What we're going to be doing is taking two equations at a time and then simplifying them. So, let's first take this first set. The fact that a plus b plus c is equal to 3 and that 16a plus 4b plus c is equal to 9. Right? So from this, we can multiply this entire thing by minus 1. Why? So that you can eliminate c. So if we do that, well, we're going to end up with minus a minus b minus c minus 3. Okay? And if we carry out this addition, well, 9 minus 3 is 6, that's equal to c minus c cancels out, 4 minus b is 3b, 16 minus a is 15a plus 3b is equal to that. On the same other side, we have 16a plus 4b plus c is equal to 9, and we have this 4a plus 2b plus c is equal to 1. So, here, we can again multiply this entire thing by minus 1 so you can eliminate c easily. So, that's minus, you've got to just inverse all these things. So, okay, minus, minus, minus. Simple, tk. Now let's carry this out. 9 minus 1 is 8, c cancels out, then this is plus 2b, and then that's 12a. 12a plus 2b is equal to 8. Now, let's take these both equations and let's, solve it, simultaneously. Oh, sorry for that. My apologies. So, the two equations that we have is 3b is equal to 6 and the fact that 12a plus 2b is equal to 8. Right? These are our two equations. Now we can solve them simultaneously by multiplying this by 3 and this by 2 so we can eliminate b. Okay? Simple. So multiplying this entire thing by the top, it's going to be 30a plus 6b is equal to 12, 36a plus 6b is equal to 24. So if we multiply this entire thing by minus 1 so you can eliminate 6b and 6b, well, that's going to be equal to, let's, use the erase button to swap everything out. So minus, minus, minus. So 24 minus 12, that's just 12 is equal to, cancels out, and then 36 minus 30, well, that's just 6a is equal to 12. So a is then equal to just, of course, 2. Simple. Now the fact that we know that a is equal to 2, we can substitute it into one of these equations. So let's take 15a plus 3b is equal to 6. So if a is equal to so 30 plus 3b is equal to 6, then 3b is equal to 6 minus 30. What is 6 minus 30 again? 6 minus 30. And then if we divide it by 3, well, b is equal to minus 24 divided by 3. So b is equal to minus 8. So a is equal to 2, b is equal to minus 8. And now that we know this, let's go back to the very start. Let's take this one. A plus b is equal to c. Let's write a plus b plus c is equal to 3. That was original, one of our OP original equations. So with this, we need to find c so we can actually write down this entire equation. So we know that a is equal to 2, b is equal to minus 8. So c is equal to, that's what we don't know. So what we can do, 2 plus, let's substitute it in here, minus 8 plus c is equal to 3. So minus 8 plus 2, well, that's just going to be equal to minus 6, of course. Minus 6 plus c is equal to 3. So c is equal to 3 plus 6. So c is equal to 9. So now that we know all this information, let's write down our equation. Equation is 2x squared minus 8x plus 9. This is our equation at the end of the day. Right? This is our OP equation for the line that passes through supposedly the points 1, 3, 4, 9, and 2, 1. Right? Simple. Now, that marks the very end of the video, and that marks everything, the very end of everything that I did today. Just a recap, quick recap. The intercept form is given by a, x minus p, x minus q. And using the intercept form, what can you do? Well, using the intercept form, you can find the xins. With the xins, you can find the axis of symmetry. You can then find the vertex. When you have the vertex, you can find the table of values. And with that, you can go a long distance. Now, what other forms did we find? We used the vertex form. Why am I using this type of pen? Okay, we found the vertex form. Okay, we also found the vertex form, which was a x minus h all squared plus k. Okay, so why would we want to use this vertex form anywhere? Well, 1, it gives you the vertex straight away. 2, it's easier to identify on a graph. 3, it gives you the axis of symmetry easily. 4, you can find the xins pretty simply. And 5, using the vertex, you can just do more table of values. Okay. Now we have the general form. The general form is the form that is, the boring form, ax squared plus bx plus c. So why is this form good? Well, it's good for all the right reasons. You can find the axis of symmetry easily, the y value, the x values, the axis of symmetry, whether it's concave up or concave down, all the good stuff, the vertex, everything. The general form is just like the OP form. I need to look into how to, get the general form into the factorized vertex form. I remember looking. I forgot. Wait. I'll show it to you in the end. Remind me. Let me write it in my paper. General form to vertex. Any vertex in general. Doesn't matter. Our basic form is y is equal to x squared, and that is just given by this standard parabola. And we have vertical translations, everything, blah, blah. So when we say ax squared plus c, the c refers to the vertical translation. And horizontal translation, well, that you'll see y is equal to x minus 3 whole squared. This minus 3, that refers to the horizontal translations. Okay, simple. We know the axis of symmetry is equal to minus b over 2a. So, but then we can also use this thing called what is it? I forgot the name, but it comes from the quadratic equation, right? Minus b plus minus root b squared minus 4ac over 2a. This b squared minus 4ac under the root, right? They just took that out. B squared minus 4ac, And you can use this in the start of any equation because, you know, if it's in the general form, you know, ax squared plus bx plus c, we know the a, b, and c. You can substitute that in to find out whether you have any roots, because you know how a graph, right? You know how a graph, it can have one root, it can have two roots, like one here, one here, one here, or it can just have no roots. See, there's no roots there. So when you're trying to, you know, kind of factorize something, maybe x squared plus 3x plus 7, it's not really factorizable. You can't really find two numbers that multiply to 7 and add to 3. So instead of wasting your time, just chuck in the digits into this minus b, not minus b, b squared minus 4ac form to see if you have any intercepts, so you don't end up wasting your time. And also remember this step yx aox v, where this is y-intercept, x-intercept, axis of symmetry, and vertex. This should always be your 4 key resorts to, you know, 4 key resorts to actually drawing the parabola. Okay, we know the concave up, concave down, we know all this good stuff. Of course, we have some problems too. What's the intercept form again? Write it again instantly. It should come to your mind instantly. The intercept. So intercept is the x-intercept. So it's x minus p, x minus q. Okay, that is the intercept form. Right? Simple. Looks like that's all I have in my book. But I wanted to show you guys something else. You know how initially we had somewhere a vertex form? Let's take that vertex form. I want to find that vertex form. Okay, that is in the vertex form. So let's write that equation down. 2x minus 3 whole squared minus 4. Okay, so vertex form. See how this is in the vertex form? The fact that 2x minus 3 whole squared minus 4, that's in the vertex form, right? Let's get it into the general standard form. So that's just opening up all the brackets and all that good stuff. So 2, well, let's write x minus 3 twice minus 4. Okay, so now let's multiply